are recording. Okay, off with these glasses. 300 horsepower, 5,000 RPM, 365 foot-pounds of torque at 3750. That is pretty doggone impressive. 365 foot-pounds of torque. That's pretty good.
Yeah, considering the older
variable cam timing, 3 valves per cylinder. Right? There's your 3 valves per cylinder. How you like that? You like the 3 valves per cylinder?
No, should be 4 valves.
Why do we need 4 valves?
Make it more efficient.
All right, it's got smaller intake valves and 1 large exhaust valve. You got that? There's not a lot of difference in the size of that. Right? Okay, the spark plug. Now listen to this. This is really important. The spark plugs in that 3 valve head require a 9/16 socket. What size is a spark plug for a normal socket? 5/8. Well, those somewhere here. Huh? This is one of them. That is a spark plug for a 5.4, and it takes a 9/16 socket to turn that.
Oh, that's one of them.
I will pass that around. Now, one of the things I'm going to tell you about this, carbon likes to get built up around down here, and what you got to do if you ever have to do these, you remember this. You hear me? Okay, break it loose, just a piece of a turn, and then get you some carbon. The stuff that you buy that's supposed to clean carbon out of and you're going to fill a big bunch of that stuff down in the hole on top of that spark plug. All right, it helps if the engine's good and warm. All right, you let that stuff, because this carbon gets hot and it gets fatter than this, and it won't let that come out of the hole. So if you can drain that, let that carbon. What am I trying to do? Carbon dissolver, you know what I'm saying. It's made for, you buy it it's for upper intake cleaning and all this kind of thing. Let it trickle down there. It's some foamy stuff. It's got the same stuff that they use for injector cleaning, the old Motorcraft stuff. But anyway, there's a bunch of different brands of it. And it's made to dissolve carbon.
Every time one of them comes in the shop, Michael tells him, there's a cough. If it breaks off and you can't get it out, you got to pull it in.
Yeah. Well, you won't have to do that. You start it loose, and you fill them holes up and let that thing soak while you go to lunch. And then you come back from lunch, you'll take it right on out of there. And if you see one that stops, you go back in there a little bit of it, put that stuff in there, and let it soak. And it's going to soften that carbon, and it's going to fix it where it'll just shear it right off of there. It won't be no problem at all. Got that?
I don't understand why they did that anyway.
Well, they wanted this to be way down in the mix where it'd be more, combustion efficient. But that's what the spark plug looks like. I'm going to pass that around. Obviously, you can't gap that spark plug. It's obviously re-gap.
Well, they got an updated plug for them now, right?
Yeah, I wouldn't doubt that. All right, right there. Pass that around and have a look at it. 9/16 socket it takes to get that out of there. And so I got one of those in my toolbox. I own a 9/16 socket for that. You can get that socket if you know where to buy it for about $10, like Tool.
The updated plug is that this bottom part is actually welded to it. Mm-hmm. Instead of just being pressed in there.
Yeah, they got it where it's less likely to come off and get down in there. Yeah. Have you had to pull the head off any over?
No.
You better not. That's all I got to say. All right. Spark plug torque is higher on 3 valve heads than on 2 valve heads. Just remember that. Look at your book. See what they're supposed to be. I'm not going to spoon feed it to you. Okay. All right. The air filter replacement procedure. Blah blah blah. Air filter slides out of the intake. Remove the air filter from the tray. Make sure the filter tray is fully seated. Now, somebody broke the air filter on my Bronco. And I think it was. Yeah, there's 4 bolts that's supposed to be took out. And somebody took 3 of the bolts out and says, I wonder why this air filter won't come off. Oh, sorry. This happened. It happened while Sean was working on it, but I don't know if he's the one that did it or not.
He did.
No.
All right. There's your mass airflow sensor. Look at the mass airflow sensor, where they put that. Is that cool or what?
Yeah, that's pretty cool.
Wow, they got it just shoved in the side of the intake there. Right. It's a compact mass airflow sensor located on the air cleaner. 2 screws hold it into the air cleaner assembly. It's real small. Doesn't have to be very big. Now look at the charge motion control valves. Have I shown you those before?
From the Mustang one?
Yeah, the one from out there. The charge motion control valve. Now see what that is. Look at it. It speeds the intake charge and it induces a tumble effect. Is that a question that I'm just asking you guys? Is that a question I'm giving you the answer to from your test? And everybody's texting on their phones on that side of the room. What do the charge motion control valves do? What do the charge motion control valves do? Huh? What do they do? They induce a tumble effect into the combustion chamber at low speeds and loads. and it causes a more thorough mix of their fuel charge, and that results in quick, efficient burn, which helps reduce emissions. They are closed at low engine speeds and light loads. And once again, I'll show it again just because I can. Just because I can, it'll cost me to do it. Here they is, right here. See, there's your charge motion control valves right here. All right, you see that? See how they close? Now, whenever they default to the open position, but whenever the PCM has got this thing powered up, they're going to close. I can make that happen. See, they close like that, and then they open whenever you need you're at your high load and all that. All right. Lay that back up there.
What's wrong with that intake manifold?
It's brand new.
Ain't nothing wrong with it at all. Is it?
No, not until I threw it down while ago. All right. It helps manage noise, vibration, and harshness, and we always want to manage our NVH.
Subarus have these too.
Huh?
Subarus have these too.
Okay. Oh, there you go. See the little thing I was just showing you? That's the little actuator. That's the motor. One electric motor operates the valve for both cylinder heads. All right. Your inputs are controlled electronically by the PCM. All right. Okay. Then you got your engine speed, throttle position, air temperature, coolant temperature. Does not use a feedback loop. What's a feedback loop? I told you guys earlier. What's a feedback loop? The computer does not know if those are closed or open. It has no indication whatsoever whether they're closed or open. What does that mean? That means it's probably not going to throw you a code. If they're closed all the time, you're probably not going to have as much power, right? Like if I wanted to plant a bug on a trailer truck that I had out here, I could make it be closed all the time and have you drive that thing. You say, man, this thing just runs terrible. It don't have no power at all. Right?
Right. They call on the Subaru. They call them solar generators.
Yeah. All right. So doesn't use a feedback loop, and it's open at a predetermined engine speed and higher RPM. They don't affect the intake charge. What's the proper stoichiometric air fuel ratio? What is that? 14.7 to 1. And that is by weight now, not volume. 14.7 parts air to 1 part fuel. That is the cleanest mix. Ain't that right, Brandon?
What? Shake your head, yes.
He's looking off somewhere.
You thinking about these?
Yeah.
All
I'm
of
thinking about sleeping.
Yeah.
them.
All right. See him. Charge motion control valves closed to help the air intake charge move more quickly at low RPM. Are you going to remember that after I've told you this 76 times?
It's easy to know. I mean,
Yeah, there you go. Good to know. Variable cam timing. Conventional camshafts are permanently synchronized with the camshaft. They don't move. When you bolt them on there, that's where they are. Now, the intake and exhaust valves operate at specific points in phase of the combustion cycle. That's what these things look like. This gear right here is connected to the camshaft, the chain that drives it, and this back part is connected, and this actually moves back and forth. See, it changes the relationship between the gear and the camshaft. As oil is pumped in there by those vanes, it can actually move it one way or another using a solenoid. It goes through there. Now, there's a bolt that goes through the middle of this. Now, what's the name of that? What do you call that bolt? Yeah. I think I would probably call it the phaser bolt. Wait a minute. How you going to spell phaser?
F-A-Z-Z-E-R.
pH.
P-H-A-S-A-R. What's it? It's not spelled like laser. Think about your Star Trek. Phaser. P-H-A-S-E-R, right? Okay, that does not stand for light amplification stimulated by emissions of radiation or anything like that. But anyway, that's what it looks like right there. Huh? All right, this is one off of that truck. Now look what we're showing here in our picture. See this? See the look at our picture up there. See it? That's the same look. This is actually the cam sensor reads off these little fingers here.
I've already had to do that. I had to do that on that 5.4.
Did you have a good time?
That was easy.
Yeah, baby.
That Nissan engine that I'm putting, that big V8, almost identical to that, but it has two intake and exhaust. I mean, it's a quad cam.
Yeah, quiet. It's got
Yeah, and it's
4 valves per
got
cylinder.
variable valve timing and all that good stuff.
Oh yeah. Now right here is the cam sensor. You see the cam sensor? That's where it's at. When you see a sensor that's right there close to one of the cam gears, you can pretty well figure that's a cam sensor. Okay, it ain't rocket science. What I don't want is to go out here and open the hood on a car and point to the fuel pressure regulator and have one of you guys tell me it's the EGR valve. Okay, we don't want to go there. Got that? because that happens with people that come from some of these, paid colleges where they get $65,000 to,
Have I ever done that?
No. That's because you came here. Okay. All right, now then. And I wasn't specifically talking about people from up there.
Yeah, you were.
But I was, there's other places I know about. But because Los Angeles had smog that was so bad. And they were actually trying to keep, get that started. Emission control started with the PCV valve on the Corvair in 1962.
Really?
Yeah.
I didn't know that.
Yeah, in 1962 on the Corvair, they put a PCV valve on it. Up till then, cars all had a draft tube. They just had a tube that came out of the block, and it was cut at an angle, so when you was driving down the road, it would just pull the pressure out of the crankcase. And it would also drip oil on the driveway and all kinds of stuff. And it coming to diesel, then in Dodge pickup trucks, they had that same thing up until the 90s.
Yeah,
Then people, some owners that didn't want it dripping on their driveway would wire a plastic bottle under there to catch that oil drip. That's kind of funny, but anyway, but basically your variable cam timing is going to eliminate the need for the EGR, and it enhances idle quality, and it's going to lower your exhaust emissions, and that's always a good thing. We don't want. I tell you what, if you guys have ever been standing there when somebody on an old radio carbureted vehicle of some kind cranked up and drove off, and when they drive by, your eyes are burning and
nothing but rich gas.
Yeah, it's just so pure old. You smell gas and it just stinks. And that's the way that's the way cars used to smell in the 1960s. Even if you had one that was running really good, and and the exhaust was, you always look for this little white, coating on the inside of the exhaust that would tell you that everything was pretty much like it ought to be. They went with the, PCV valve came first, and then they followed up. They put on EGR valves right before catalytic converters, as I remember. Catalytic converters came out like 74 or 70 or whatever. Early 70s, and that kind of thing started cleaning stuff up. The catalytic converter is going to get rid of the oxides of nitrogen by breaking the oxygen and nitrogen apart again.
How do you do that?
It's like the catalyst is inside there. It uses the heat, and it uses these platinum, palladium, rhodium, and it's got this brick that it processes every last little bit of that gas, and it's going to make sure that whenever that heat's in there, and a catalyst is something that can change a compound of something else without undergoing a change itself.
Right.
That's what that is. So that's what that catalytic converter, the front brick, the light-off cat that starts the process, is the one that gets rid of the oxides of nitrogen. And there's another cat downstream. Might have got two cats. You have one here. The second one gets rid of hydrocarbons and carbon monoxide. Right. And the way it does that is the hydrocarbons get two more molecules of oxygen. Oh, that was great. That was the delayed reaction print, if I ever saw one. But anyway, the carbon dioxide is formed when you add one more molecule of carbon to carbon monoxide, and you add two more to hydrocarbons. The hydrocarbons are basically a carbon molecule that's got no oxygen with it at all. And typically, you're going to see that it's going to show up as soot. Heavy soot, and like black smoke and all that kind of stuff. Carbon monoxide is clear, colorless, odorless, and will kill you dead. You shall surely die. But anyway, we get into that pretty heavy in emissions, which comes this summer. We'll be talking about that. We'll even have an exhaust gas analyzer connected so you can see this stuff. And you can understand that if you disconnect an injector, it's going to skip on that cylinder. If you disconnect a spark plug, it's going to skip on that cylinder. But your gases coming out of the pipe are going to look totally different, even though it's skipping on the same cylinder. It's a different thing. You're taking the gas or you're taking the spark and all that. So anyway. So theory of operation for your 5.4 liter variable cam is similar to the 3.9 used on the Thunderbird. Okay, it controls intake and exhaust because the 3-valve setup uses one cam for both intake and exhaust valve. Got that? It's not controlling just one of the cam shafts. In other words, it's controlling all of the valves instead of just one set of them. On the Contour, when it closed those valves a little bit early, the exhaust valves a little early, it left some of the exhaust gas trapped in there. And that's what gave you your lowered combustion chamber temperatures.
That's why you didn't have to have EGR.
That's exactly right. So you didn't have to need it. And you don't need it on this one for the same reason.
Why do they most of the time only put variable valve timing on the intake?
Well, it depends on whether you're going for exhaust emissions or power. See what I'm saying? I mean, if you want more power, you're going to put it on your intake cam typically. That's just the way that I read it. Okay, and one of the things that this guy one time had this 73 Bronco that he had put a Mustang engine in it, and he cammed it up. And so he had the wire harness and all of that stuff put on there. And he put that thing, and he had a map sensor hooked up to him, and that was how it was, figuring its fuel and all that. And this thing just idled rich as a dog when it was cranked idling, but it ran good going down the road. But when it was idling, it ran really rich because when you cam one up, the vacuum goes down. Right. Intake vacuum is low on a cammed up engine. And that told the PCM, hey, I've got a load. And so what the PCM was doing there is it was putting more fuel in there because it thought it had a load. So what we had to do with that, we got a $500 mass airflow conversion kit. And it came with a PCM, a partial wire harness, a mass airflow sensor, and it was really cool. There was a little box that hooked in series with a mass airflow sensor between it and the PCM, and it had a little screw on it, and you could adjust that mass airflow so that it was perfect.
That's just how, like, my cars, every one of them got it's called a super airflow converter.
Yeah.
It goes in line with the.
Yeah.
One of them goes to the. One wire goes to the PCM, the other wire goes to the mass airflow sensor.
Yeah, and you can actually turn it and look at your little numbers on there and change it where you want it to be. But and that was cool, and it fixed that problem too. Now this is one of those guys where this guy paid to have this Bronco painted and paid to have the engine put in it. If you're restoring a vehicle by yourself at home, the labor you're putting into it is basically it's a hobby thing, right? Well, this guy starts hiring people to do it. He had like $30,000 in that thing. It wasn't worth what he had in it, But whatever. All right, now then.
That's ridiculous.
Yeah, I know, but
$30,000.
well, he had a lot of money, I guess. But anyway, now the variable cam timing can vary cam timing within a range of 60 degrees of crankshaft rotation.
Dang.
How much is that of camshaft rotation?
The camshaft turns.
How far does the camshaft turn while the crankshaft is turning 60 degrees?
I don't know, but I know every 2 revolutions to the crank,
Can you divide 60 by 2?
Nope, I can't. Yes,
30 by 2.
30.
You could if it was money. Anytime you're thinking numbers, think money. You can always figure it up when you're thinking, when I teach somebody to do it like it's money. Okay, it requires engine oil at preset temperature before it'll function. The engine oil has got to be the right temperature before it'll work. Oil from the retard and advanced passages flows into passage in the head, through the head and the camshaft, through a camshaft into the rear of the camshaft, timing rotor, and then so on and so on. The phaser sprocket is what I was just showing you with those veins in there, okay? Now then, hydraulic timing mechanism rotates the camshaft in their drive sprockets. It provides performance that's precisely tailored to the engine speed and load. See, that's a better deal, okay? And it's electronically controlled and hydraulically operated. It moves spool valve to control the flow of oil into the, so on and so forth. So it's going to flow through the valve body, into the chain tensioner, through a metered orifice, back into the head. Let me tell you something about these motors here, guys. You better put the right oil in there, because if you don't, it ain't going to run right. So, don't say, hey, I think I'll just pour this guy some 2050 in here and he'll be happy, because he won't be. You need to put what it calls for, because when the oil is doing the kind of work that we're talking about here and it's going through little small orifices and everything, it needs to go through there at the right rate and all that. Brendan knows there. He's all, look, he shall surely die. Oh, man. Shoulders are all turned. My phone is ringing out there, but they'll just have to wait. Okay. 5.4 3-valve camshaft position sensor. All right, you got that? There you go. Now look at this. Ooh, oil temperature sensor. It's got that. Now, what other vehicle had an oil temperature sensor on it that you ever heard of?
I put one on mine.
Power Stroke diesel had it. The 7.3 Power Stroke diesel didn't give a rip what the engine coolant temperature was. Couldn't care less. But it needed to know what oil temperature was.
Why?
Because it used oil fired ejectors.
Oh, yeah, okay.
All right, you got that?
Yep.
Okay, engine oil temperature, direct effect on VCT operation. Why? Cold engine oil flows slow. And the VCT system is, is disabled at oil temperatures below 18 degrees Fahrenheit. We talked about that before. Same thing. We talked about that the other day, right? Huh?
Same as at 3.9.
Yeah, sure is. Engine oil recommended drain intervals. Ooh, you better change your oil on time, too. All right, you got your right and left camshaft phaser sprocket, right and left camshaft phaser sprocket, bolts, washers, VCT valve bodies, VCT solenoid, right and left camshaft. You got all that stuff. We got parts we never used to have. Oh, that looks just like what I was showing you, doesn't it? There's your phaser oil veins. See? There's our little phaser oil veins. See that right there? See the oil veins? How they move back and forth? There you go. All right, it's all took apart. There's a big old spring in there. It just stood. See how big that thing is? That's so that it'll default.
Okay.
See that? It's going to default. Now, what is that right over on the very end?
That's the phaser bolt.
That's a phaser bolt, right? Okay. All right, let me see. The phaser is only serviced as an assembly, but you can take it apart and look at it if you want to. There you got a locking collar and a pin. You got to always put a new bolt washer in when they remove. Did you hear that? Did you hear that? Always put a new bolt in it. Don't put the old bolt back in there.
Why?
Because it stretches a little bit and you don't want it to go pop, spins out of time, spins all the valves, had to have, all kinds of big work and all that. Don't take any chances on that kind of thing. Is that right, Archie? That's right. Man, go there, buddy. All right, now that right there.
Hey, go back up. Go back up. There was an extra one of the things. Go down.
All right, let me see.
Come on down.
I get read.
Another cam head will drop.
Damage will occur if dropped or mishandled. We were talking about an ohm meter yesterday and how you're never supposed to use your ohm meter to measure a circuit that's got current flowing through it. There was a shop manual that was written bad when we were over there with Ford. And Donnie had his meter, and this is a meter, he had one just like the one I had. We bought them meters from Radio Shack. When you couldn't hardly get a digital meter nowhere, you could get one from Radio Shack. I bought one from Radio Shack, paid about $50 for it. He bought one similar to it. And he was over there, and I was coming up behind him, and I'm not a great proponent of playing jokes on people, but he was just standing there with his meter leads in his hand. I didn't think he was going to do no harm. I come up behind him with this bubble paper. You know how when you do the bubble paper like that, it startles people? And so he wasn't holding anything dangerous. He wasn't going to kill himself or nothing like that. So I come up here, and I've got this bubble paper, and he's thinking, what I didn't know was what was going on in his mind. He says, this book is telling me to check this live circuit with my ohm meter. I'm not supposed to do that. That's bad for the ohm meter. But the book says to do it. I should do it because the book says so. No, I may damage my meter. Well, if the book says to do it, it must be right. He's thinking, about the time he touches that, I go, what? He goes, oh! And he says, I just knew I was going to damage my meter, and as soon as I heard that noise, he said, damage has occurred. That was so funny to me. He said, and he told me later, he goes, I cannot believe how good your timing is. Anyway, he was a young guy, so he wasn't likely to have a heart attack. Okay, now then. One time I took this turn signal flasher that I plugged out. I plugged another turn signal flasher in, the turn signal wasn't working. And I said, yay, I can throw this at the trash can. And so I ring my arm back to throw, and Donnie's sitting at a computer, which is kind of by the trash can. And I'm saying, gosh, I hope I don't hit Donnie in the back of the head with this. And I threw it at the trash can, but my eyes shifted to his head, and it bounced right off the back of his head. You know how wherever you look, when you hit your finger with a hammer, because you looked at your thumb, Look at what you're hitting. VCT solenoid is serviced separately from the VCT valve body. Okay, no special tools are needed. Hey, that's cool. So you disconnect the solenoid electrical, remove the grommet, pull the hold down bolt out, remove the solenoid. Now look at there. Wow, that looks like, what does that remind you of, Archie?
Transmission.
From transmission part, don't it? Anytime you got those passages cut like that where the fluid flows through, you got a solenoid filter, oil passage, you can figure all that stuff out. All right, now see right there? Now your phasing, the locking pin, locks the camshaft in a fully advanced position when the engine is off. And that locks the phaser during startup. You don't want the camshaft moving during startup, right? After startup, the oil pressure in the VCT assembly unlocks the pin. And that lets the VCT... Do we have oil pressure when the engine shut down?
Yeah.
What? When the engine is shut
Hey, I
off?
seen somebody the other day cut off their truck and their oil pressure still sat at like 20.
Well, that's because of the gauge, not because they still have pressure. Okay, VCT does not control valve time until the oil temperature reaches 110. Isn't that something? We heard earlier that it wouldn't work below what temperature?
18 degrees. Hold on, that's not right, Archie.
No.
It does not control valve. Now, we were talking about that. Okay. All right, makes it easier to start the engine, reduces noise on startup. We don't want noise on startup. Noise on startup is bad. It's not our friend. All right, the camshaft and or the camshaft phaser can be removed and replaced without having to remove the front cover. You can do it without pulling the front cover off, guys. That's good. All right, now let me hit you with this. Number 3. Somebody read number 3 question to me.
The new engine's outline is outfitted with EGR.flv.
What's that now? Number 3?
Yeah.
ERFS.
I don't know what that means.
What does that mean? The blank, the gasoline Super Duty engines. Yeah. Yeah. Now, what is that acronym you were giving me?
I don't
Engine rear front seal.
Engine rear front seal. Very good, Brandon. I'm impressed.
Is that what it means?
No.
I was going to say.
Rear front seal. I was thinking about how wonderful that is. All right. Okay, what is that? An ERFS. An ERFS. Let us keep paying attention until we know what an ERFS is. We going to do that?
ERFS.
Yeah. All right, ERFS.
Engine rear front seal.
No, it's not air engine rear front seal. All right, here's what you're going to do. Look at this. Let's make this out. We're going to remove the left and or right valve covers, whichever one that you're going to change. You're going to set your crankshaft damper notch at the 1 o'clock position. See your damper notch? That little notch is set in there as you ordinarily look at the timing mark. Notice where we're putting that. Now, where's these other marks over here? Look at other marks on the other side. Are those your TDC and 10-degree CDC marks, you think? Over there? All right, now then, you're going to put it at the 1 o'clock position. Now, where you see it in the picture, you see the arrow pointing at it?
No.
All right, that's where you're going to put it. Do not forget this. Look where they got it. You can kind of use that for a reference point. You're going to put it just a little ways before you get to that.
That's
Yes,
what we
is it?
did when I did mine.
Huh?
When we did that 5.4, that's how I did it.
There you go. So number one piston should have just passed top dead center when the crank was turned to the normal rotational direction of the engine operation. Now, just because you got that right there doesn't mean you just passed top dead center compression, but they don't even talk about compression or exhaust here, right?
No.
They just say TDC. All right. All right, now look what we got here. Cam lobe positioning. Position the cam lobes with the exhaust lobe facing inward. If they're not positioned that way, the crankshaft will require an additional rotation. Oh, now we're talking about compression versus exhaust. You know, and that's how they have you determining which, if you got the valve cover off anyway, you can look at the cam lobes and tell if you're on a compression or exhaust. Right? That's part of engine repair. It's what we're here to learn, okay? The number one cylinder camshaft exhaust lobe must be coming up on the exhaust stroke. All right. Now then, we're going to mark our damper. See, this is our mark that we just stopped right there, and we're going to put a mark dead on the 12 o'clock position, right? It's got to be pointing upwards just to the left of the machine notch. That's the one with the keyway cut in it, right? That's the damper spoke. That damper spoke is the one with the keyway. Now, on most engines, when that's straight up, you're on TDC, right?
Yeah.
But on not on all of them. On a 350 Chevrolet, it's over here. Ain't that weird? All right. All right, now look at that. Now then, this is what we're doing. We're going to, now pay attention because, Brandon, you may have to do one of these next week. All right. Loosen the camshaft phaser bolt one turn. Do not remove the bolt. Do not use an impact wrench when loosening the phaser bolt. Don't grab your little 3/8 drive impact and wham! Not good. All right, impact tools can damage the internal phaser components. We do not want to damage the internal phaser components. All right, are you seeing an answer to a question over, Brandon? Which one is it? Tell me.
Number 7.
Number 7. Oh, here you go. Now, Brandon just caught that. Very good, Brandon. All right, now then, remove only the indicated followers. Have any of you guys ever removed cam followers like this?
Yes, I surely have.
You surely have. What about you, Sean? Have you removed those cam followers? You don't remove them all. You have to.
Full with a head that had the cams in it.
I thought he did. I thought he removed some. Anyway, y'all were
The
fighting
Dodge
with
had
those.
cams in the head.
You did them on the other.
Y'all did too.
Yeah,
Y'all done it on
the
the
Dodge.
Dodge.
That's what I was saying. The Dodge had cams in the head.
It's exactly that same kind of cam follower. See them right there? That little thing that you pop out over a screwdriver? That's the same deal. Withdraw the exhaust follower toward the exhaust valve tip. Withdraw the intake follower toward the intake valve tip. Number 1 cylinder, exhaust only. Number 4 cylinder, both intakes. See that? Those are the ones you're going to pull out. Right? And they got you using a valve spring compressor to do it on that one, you know. Okay, now then, look at this. What are you going to do now? This is complicated, isn't it? You better do it right. You got me? You better do this right.
Yep.
Rotate the damper to the 6 o'clock position. It's imperative that only this arc of travel is followed. Do not go beyond the 6 o'clock position and think you're just going to back up. Got it? The only time the engine is turned back to 12 o'clock is during the assembly procedure. Okay, here we go. All right, now you got a wedge tool. All right, inset timing chain wedge tool. You know what we used to use? Oh, yeah. You're going to put it between the chain spans. 6 to 8 clicks will hold it. Mark the chain to the phaser. See, what you're doing is when you take the phaser out, You don't want the tensioner going, You remember those tensioners? You don't want it pushing that thing together because then you can't get it back on there. So you got to run this down in there. And did you know, by the way, what we used to do at the Mazda dealership back in the early 80s when I worked there? We had a timing chain on some of them pickups that was like this. And we had to take a wedge-shaped piece of wood and drive it down in there real tight when we were taking that stuff. That was what that's what Mazda said to do, was get a wedge-shaped piece of wood. It was just the right size. And that keeps that tensioner from pushing those chains out. Got it? Because if it does, if you mess up, you guys are going to be, you're in hot water. So don't do that. All right, mark the chain to the phaser for installation. How are you going to do that?
Nail polish or something.
Well, yeah, I'd put some white out or something like that. You clean it off, put some white out on it, works pretty good.
White won't come out.
Yeah, it stays there. Yeah, you can put it on, a girl can put it on her fingernails and she will not get it off with that stuff. I mean, it's tough. It's bad stuff. It's
White out?
Yeah, white out. White out is seriously permanent when you put it on something. Just bad. As a matter of fact, somebody would drive an engine 100,000 miles, you may still see that white out on that chain.
Even if you try to wash it out with a parts washer.
Yeah. If white out would come off easy, it would have no reason to be there. See what I'm saying? They had to design it that way. Okay, loosen the cam bearing caps. Now, what are we doing here? Loosening the cam bearing caps. We're going to start with the number 1 cap because it has a thrust surface groove in it. If it were to be moved in some fashion with this cap intact, the cap could be damaged or broken. If you break the cap, you are toast.
Yeah, because
you just got to put a head on it. You don't just go buy a cap because they're perfectly made to match that head. Got it? You may get lucky and find one that'll work. It ain't likely. Unless you got 700 engines out there and you can pull one off any of them you want to. All right. Remove the remaining cap bolts according to workshop manual procedure. Okay, now you're going to, the phaser bolt. That's that question right there. The remaining followers will be loose on the lifters. Make sure you put them in place so that, see, we loosen all of these cams. The cam is actually going to be loose rattling around on there. Now, did you guys have the idea that if you change this, you're just going to spin that bolt out with an impact wrench, pop it on there, and go back down? See how much trouble you got to go to? This is why this kind of thing right here is explaining why it is that you need training to do this kind of work.
You don't do that training.
Yeah. Remove the cam position sensor. Pull the camshaft sprocket phaser bolt by hand. Screw it out of there with your fingers. All right. Now look at this. We're going to remove the phaser and pull extreme care. I'm going to pull the phaser from the nose of the camshaft. You might be able to tip the cam up from the rear to allow chain disengagement. See what we're doing there? All right. Now, that looks scary, don't it? Chains hanging out there and all that. Okay. Care should be taken to ensure that the remaining followers are properly seated before you put the camshaft back in. All right. There's your phaser pin and cam notch. You see where that goes? See the marks? You got a mark on that cam, and you got a mark on your phaser. See 1 and 2, phaser pin, cam notch. You got to line them up. If they're not lined up, the phaser and the camshaft will be damaged. See, in other words, that gear goes on the end of that shaft. You got to line that number 1 item up with number 2. If you just kind of cram it on there, that's not going to work. You're going to get in trouble, mess it up. That's right. Now, if you notice this, and Brandon is getting better and better at doing this work. He's getting confidence now. Have you noticed that? Hey, there, Brandon. Brandon did a full brake job on the front of his truck yesterday. You know how much it cost him? $16.99. He turned the rotors. He bought the pads. He popped them on. He got his brake point. All right, there you go.
Does it shake?
Yay.
It does shake?
No, it shakes, but not when he's braking. It shakes only when he's driving.
It shakes between 55 to 65.
And he's got a bubble on his tire.
Oh, that's real fun.
Yeah, it had a leak forever, and some of the air got between the tread and the
It's
belt.
like most of like yesterday. I noticed most of the tread is worn, but like
Yeah,
much all the way around. It's like this much higher than the other.
you know what you got on that? You have actually got. Now listen to this, guys. What he's got one bump on that one tire. He's got a first order vibration because he's got one bump on the tire. Every time a tire goes around, he feels a whoop, 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 like that.
That feels good, though.
Yeah.
No, it's annoying.
No. Okay, install the bearing caps in reverse order, so on and so forth. Put the phaser bolt in. How do you put the phaser bolt in? With the impact wrench or what?
Yeah.
Rotate the crankshaft pulley back to 12. Tighten the phaser bolt to 30 foot-pounds plus 90 degrees. Now, what's 90 degrees? Brandon, tell me what 90 degrees is. That is actually 15 minutes on the clock, right?
Yeah.
Bingo.
I don't like that kind of crap.
What?
I really don't.
It's actually a little torque to yield thing. It's for real mechanics, not second rate amateurs. Okay. All right. Second rate amateurs usually don't like it. Okay. The 6.8 was upgraded with 3-valve technology similar to the 5-port. That's one like in that van we got there. It's the most powerful gasoline truck engine in the heavy duty truck segment. 355 horsepower, 455 foot-pounds of torque, and the EGR valve is deleted because they don't need it anymore with VCT. All right.
Yeah, just about.
Now listen to this. Even though, now get this, guys, don't miss this.
V6.
All right, uses
What motor is this?
this is a V10. Yeah. Solid sprockets instead of a phaser. A similar procedure can be used to remove the camshaft without.
Hold on.
What?
Go ahead.
Why'd you find an answer?
Hey, hold on, Mr. Reggie. What kind of V8 is this?
Why that one there? That's a 6-liter.
How many horsepower did you say it had?
That was a 6.8 there.
How much horsepower?
Oh, how much horsepower did I say it had? At 355?
Ain't a lot.
It's not.
That's really not a lot because my truck right out there pushes just about that at like 3.6.
Really? What kind of torques it got?
I don't know, but it's a V6. I got a V6 out there.
Yeah. Well, what's your torque is what's going to move a load.
My
You know what I'm saying?
4.5 liter has 365 horsepower and 410 foot-pound of torque.
That's pretty strong.
Yeah, it is.
Yes, sir.
I should look it up.
Hold on, now the number 9 says the EGR valve on the 6.8 engine is a new design. That's false because it doesn't have
It's
it.
deleted. That's right. There's not one there.
Oh, that's
Now, this is a 6-liter diesel V8 engine. And it's improved to reduce. It's got, listen to this, 320. Look at the, there's not as much horsepower, but it's got more torque. What's up with that?
Because it's a diesel.
325 horsepower and 570 pound-feet of torque. And you can get it either with a single or a dual alternator. Injection pressure regulator. Yeah, you can get 2 alternators on it.
That's pretty cool.
Now, the improvements for the 2005 included an upgraded injection pressure regulator with a 200 micron internal filter of 2005. Last year, it had a 150 micron filter. And that's going to be on the pop test at the end of the semester. Okay? Remember that. Now, look at that. Stationary elevated idle control. Auxiliary PCM has been eliminated and replaced by the stationary elevated idle control. You know why you need that? On ambulances and stuff, or on anything that requires you to have it sitting there with the engine at elevated RPM, you got to have that. You're going to be able to just punch a little button and
Really?
go where it wants to be. Like it's like heavy duty stuff, like in
Like a
commercial,
backhoe?
something like that. Yeah. Builder interface instructions. We used to do that. All right, now look at this. The EGR throttle plate. Now the EGR, the 6-liter does have EGR. And it's been eliminated. So airflow plates or directors. Okay, how many questions do we still like there? We done?
Number 3
Number 3?
and number 4.
Okay. All right, you got a new scoop. A new up pipe scoop. Helps EGR grab some stuff. And there's your variable geometry turbocharger solenoid. You can put one of those on your Nissan there.
I'm going to.
Yeah.
Thought about it, really did.
This right here is the high pressure pump. That right there is the pump discharge and branch tube that feeds both branches of the oil rail. There's your water inlet location.
What does it do, Sean?
Huh?
Turbo gets bigger and smaller.
There's your injectors right there.
Awesome.
That's gasoline, though. Oh, what's this? Whoop, whoop, whoop. Read that question. That's number 3, isn't it?
Electronic returnless fuel system.
Electronic returnless fuel system. See, we whipped through a 51-page handout and nothing flat.
There's about an hour.
All right, now you see this? This is actually what's on that Crown Vic key out there. See that? You got a fuel pump driver module. That fuel pump driver module is going to decide how much voltage goes to that fuel pump.
Electronic returnless fuel system.
All right, you see that? Now, what I'm going to do is I'm going to give you guys a diagram of this gas tank, and you have to diagram every one of those lines and tell me what they do. Can you do that,
What?
Brandon? Yeah.
You want a zero for a test?
There's a ring that goes around the top.
Show is. That holds fuel
No, it's
pump in
not.
there.
It looks like a ring.
It's a gasoline engine cam lock retainer.
Yeah, I'll try to tell you.
All right. Special tool 310-123 is required to move the fuel tank center. I bet we can
Oh, a
probably.
flathead screwdriver.
I believe,
Yeah.
huh?
Flathead screwdriver.
Yeah, and a hammer.
Yeah.
What engine has that? The
What?
RFS That's the question.
The gasoline engines.
Oh, the Super Duty engines.
Hey, okay, the VCT valve body and cylinder were together to route oil to the what?
Nobody, ain't.
Wait a minute.
Probably to the phaser sprocket.
Which question is that?
Number 4.
Oh, 4. It's the vanes in the camshaft phaser. You knew that.
I thought so.
Yeah, that's what it said.
Dang.
In the phaser.
Well, phaser's on stun. You got that?